Okay, this video I believe is going to be very helpful to a lot of people. One of the problems with the pulse motor is being able to measure our amperage that's going into our charge battery. Measuring from the run battery is not a problem, we can do that, but because of the high voltage spikes coming out of our charge side, we can't just throw a meter between that and the battery. And how do I know this? Well, that's how I know it. They're all fried. Learnt the hard and expensive way. So the other way we can do this is by going from our high voltage side into a large cap, and then from that cap through our meter and into the battery. So that will show us the amps that we're putting into our battery at that battery voltage. Now, the problem with that is, of course, we then kill the high voltage pulses going into the battery. Now those high voltage pulses are the very reason we've got this motor in the first place. So once we get rid of that, we're no longer conditioning our battery, and we might as well just hook it up to a standard battery charger. There's an answer to this, and I'm going to show you that, how we can get a amp reading going into our charge battery and still be putting the high voltage spikes into our charge battery without destroying our meter. So to understand how this works and why it works, you're actually going to have to leave conventional current flow behind and deal with real current flow, which is a totally different subject. So for the purpose of this demonstration, we'll just not go into that. We'll leave it as our conventional current flow theory. Just going to grab the Daft Man's diagram, this good old trusty diagram that most of us use. And now what I'm going to do is start her up, turn our meter on. So I'll start it up, I'll wind it right up, and then I'm going to back the pot right off, let it settle, so we can get our amps that's going into our charge battery. So we'll do that now. And this motor takes a while to wind up because I've got the coil set a fair way back from the magnets. I can put it a bit closer, and it starts to get a bit noisy on the flywheel because it's hitting the magnets harder when it pulses. It will charge a lot better, but also pulls a lot more out from the run battery, so I found that position to be the best. So I'll just let it build up the speed a bit. Okay, so now I'm going to turn the pot right down. And of course the rotor's slowing down. I'm going to leave that for a little while to settle. Now from the bit of testing I've done before I made this video, it's about 21-22 milliamps it should settle at before the rotor stabilises in speed. So this demonstration is not to show us pulling any current off of the run battery, because we can already do that simply by just putting a cap in there and our meter between the cap and the battery. It gives us an accurate draw reading as far as amps go. Okay, as you can see, she's pretty much well settled, some 20-21 milliamps. I hope you can see that. So okay, we've now worked out that we're putting 21 milliamps into our charged battery, but we've killed the high voltage pulse through the big cap. So now we're going to show you how to do this by allowing the high voltage pulses still to go into our charged battery, and also get an accurate amp rating into our charged battery without totally frying our meter. So I'm just going to disconnect all this, and I'm going to hook it up as per normal with our high voltage line going into our charged battery. Just connect the lead that goes from our positive of the run battery to the negative of the charged battery, and I'm going to hook our multimeter there instead. So what I've done now, I've got rid of that green bridge from the positive to the negative, and I've put our amp meter in between the positive and the negative instead. So now we'll do the same test. Once again, I'll let it pick up speed. And once again we'll leave it for a little while until it settles. I'll turn the pot light down once again, so we'll leave it a bit until it settles. Still winding down a little bit, just about there. Okay, that's pretty happy there, doesn't seem to be changing. So what I'll try and do now, 21 milliamps, exactly the same. Difference is we've got our high voltage pulses still going into our run battery. If we disconnect our run battery, you can see the amps drop down to 0. Hook it back up, straight back up to our 21 milliamps. So this is very good, because now we can really get some accurate readings of charge rates, and also we can do our draw rates on our run battery. So that's how you do it, guys. Won't kill your meter. One way to soften out the pulses is to put the cap in, of course, but it kills the pulses to the battery. This way we can use our battery on the back side so it doesn't toast our meter like I've done many times, simply by hooking it, like I said, between the positive and the negative. Set it to your amp setting and there you have it. Still on 21 milliamps. Stable as, no flickering, nothing. So now what we can do is at the start of our charge cycle we can have a meter hooked, 2 meters hooked up to this, one for voltage, one for current draw. We can have our 2 meters hooked up to this, one for voltage, one for current draw. At the start of our charge cycle we can write down the total watts being drawn from the run battery, and we can write down the total watts being put into our charged battery. At the end of our charge cycle we can also take an amp draw reading from our run battery, an amp draw reading from our charged battery, or an amp input to our charged battery, sorry. We can then let them sit, get our rest voltage, put that with our charge or our amp draw and our amp charge rate, get the wattage from those two, add the 2 up on the run battery, add the 2 up on the charged battery, and that in fact will tell you if you have put more into your charged battery than you have taken out of your run battery. But remember, it must be left sit for a couple of hours so they both can obtain their rest voltage to get that last reading. So I think that may have helped us out. And the reason I've done this because I wanted to know what the amps was going into our charged battery with the high voltage spike still going in there, and haven't been able to do it. So after some heavy thinking, that's what I've come up with, and it works absolutely beautiful. Still on 21 milliamps. So that's, I believe, solved a big problem everyone was having. We will now be able to get accurate calculations of our charge rate compared to our draw rate on our run battery. Okay, till next time, cheers from the Tin Man.